We're going to talk about solving systems with three variables now. So section 3.6, last section of the chapter, and it's solving systems with three variables. So our answers today will be x, y, and z. We're going to be solving systems and get an ordered triple for our answer. Very similar in a sense to solving systems with two equations, just a lot more work, really. All right, but solving systems with three variables, very tedious type problems, but again, the work really is not too terrible. We're going to talk today about the elimination method. So solving systems with the elimination method is, I think we can all agree, probably the easiest method. They all agree with that? Okay. And solving systems, three systems, it's a lot easier to do the elimination method. All right, so what happens here is we're going to get three equations. Now, when we do this, we need to eliminate the variable from both of them. So what happens here is we eliminate the y's on both of them, leaving us with then a two-variable equation. From there, I take these two variable equations down here, and I set them up to eliminate a second variable then. So really what I have is we have like our primary equations, then we have secondary equations, and then we kind of get answers. These would be like our secondary equations right here. Okay, because I'm going to get them second after I eliminate a variable. Now I set them up from this step right here. It's all the same process from what we've just been doing, where we eliminate. All right, that's going to be the same exact type of problem that you just did on the warm-up. All right, it's this part right up here that is the new part. This would be all the new part. From there on, though, it's everything you know. You know how to eliminate variables in two variables. All right, and then at last, our answer is going to be an ordered triple, not an ordered pair. Now remember, ordered triple is x, y, and z. All right, so let's look at the first problem. You're going to need a lot of room on these problems. So make sure I'm probably going to have to erase even a couple times just to make sure I get it on. As I look at this, again, systems of three variables, what variable would look like it'd be the easiest to eliminate? It's almost set up already to eliminate. John, what do you think? The y. If I look right here, my y's are already set up to eliminate. So in order to eliminate them, they're going to share this middle one. So I'm going to set those two up to eliminate the y's. And then I'm also going to set these two up in order to eliminate the y's. Because I have to do it twice, so I get two different equations. So I'm going to rewrite those top two. So x minus 3y plus 3z equals a negative 4. 2x plus 3y minus z equals 15. That's those top two equations. I'm going to do the same for the blue ones now. So the bottom two. 2x plus 3y minus z equals 15. 4x minus 3y minus z equals 19. The hardest or the biggest struggle I've seen from students today is they copy the problems down wrong. It's not that they can't do the work, it's that they literally copy the problems down wrong. That's about the only mistakes I've seen from students. Now I set these up to eliminate. What am I going to eliminate again? Eliminate the y. Eliminate the y and I add down. X plus 2x gets me 3x. 3z minus z, I get 2z. Negative 4 and 15 equals 11. So 3x minus 2z equals 11. Same thing on the other one. I eliminate the y's. 6x, what's plus 2z? 6x minus 2z equals, is that 34? So I have 3x plus 2z equals 11. 6x minus 2z equals 34. From here now, I'm going to take both of these equations right down here and set them up to eliminate again. So 3x plus 2z equals 11. 6x minus 2z equals 34. Now from here, do you see how this is a problem very similar to what we've been doing? Yes. From here, it's all the same type of work. What would I eliminate now, Garrett? Yeah, I would set up here and I eliminate my z's. And I add down, getting me 9x equals 45. Divide by 9, and x comes out to be what, Garrett? 5. Thank you, sir. So I get x equals 5. I have one answer. From here now, it's just going all the way back, all the way through, solving for my other variable. So I'm going to take x, I'm going to plug it in to one of my secondary equations to solve for z. So I can plug it into either one of those secondary equations. I'm going to plug it into the first one. I just felt like that. So I get 15 plus 2z equals 11. Subtract 15. 2z equals negative 4. Divide by 2. Z equals a negative 2. Now I have two of them. Now I'm going to take both of these, and where do you suppose I'm going to plug both of these back? Into one of the very first equations. From here I could pick either one, it doesn't really matter. But I'm going to take this, I'm going to put it all the way up into the, let's say the top equation. Just because I feel like the top equation. So I'm going to put that all the way back up there into the top equation. Getting me 5 minus 3y minus 6. 3 times negative 2 minus 6 equals negative 4. And from there, I'm solving for y. So I add 6 to the other side. 5 minus 3y equals 2. Subtract 5. Negative 3y equals a negative 3. Divide by negative 3. I get y equals a negative 1. Now I can put my ordered triple. I have all three answers. I put them in the order x, y, z. My answer would be 5, negative 1, negative 2. All as an ordered triple. It's a very long process, kind of tedious, but really as you look at it, this is all like right above where I star here. That's really about the only new stuff. It's all above that. Everything below, you can solve systems of two variables. It's getting them down to that that's going to be the new process for you. All right, and then from there, you're just going to go all the way back through the process, plugging back in to solve for all the indicated variables. And again, the elimination method is by far the easier of the three with systems of three variables. Let's try another one here. I'll help you get started. So number 2. 2x plus y minus z equals 5. 3x minus y plus 2z equals negative 1. And x minus y minus z equals 0. As I look at these, which would I like to eliminate probably first? Which one looks to be the easiest to eliminate first? The y. Yeah, look at the y again. Why do you say the y? Yeah. I'm going to pair up the first two, and then I'm also going to pair up which one? Yeah, the top and the bottom one. Now I can set them up to eliminate. I can skip one, that's okay. So I'm going to eliminate the first two and the first and the third. So I get 2x plus y minus z equals 5. 3x minus y plus 2z equals a negative 1. There's the first one. Second one now, so I'm taking the top one and the third one. So 2x plus y minus z equals 5. X minus y minus z equals 0. And then both those, what do I want to eliminate, Reagan? The y. So 2x plus 3x, I get 5x. Negative z plus 2z plus z equals 4. I eliminate the y as my other one. 3x minus 2z equals 5. From here, now I take both these equations down. So 5x plus z equals 4. 3x minus 2z equals 5. Now, these are not set up already to eliminate. So what am I going to have to do in order to eliminate here? What do you say, Phil? Yeah, very good. I can multiply the top equation, all of it, by 2. So I'm going to do that. That gets me 10x plus 2z equals 8. Solve it from there on your own. All right, I'm going to start walking through this slowly here. Next step would be to eliminate the z's. Gives us 13x equals 13. Divide by 13, and I get x equals 1. From here, I plug that into one of my secondary equations. I'm going to plug it in right here, that top one. So I get 5 plus z equals 4. Subtract 5. I get z equals a negative 1. Great. Now I take both of those, and I plug both those into one of my equations. I'll plug it in there. I get 1 minus y plus 1 equals 0. Subtract the 2 from both sides, so you get negative y equals negative 2, which is really y equals 2. And then I get my order triple, which is 1, 2, negative 1. And again, make sure at the end you put out your answer as an order triple. All right, good work there. Saw a lot of you guys are doing great work. Try this last one all on your own here. Now, as you look at it, I will give you a hint. Which one would probably be the easiest to eliminate, Andy? The z's. I would look to eliminate the z's first. As you're working on it, I'm just going to start working through it a little slow here, so you can start checking yourself if you get stuck.
You can plug these both into any equation now, right?
Mm-hmm. Yep. Again, this right here, this first process right here is that big thing you got to make sure you do correctly. Set them up to eliminate and try and get them down to 2 variables. From there, once you get 2 variables, it's very similar to everything we've been doing. All right? Here is your assignment when it comes up. There we go.